Convex concave rule. That may create some emotion in some physical therapists. It is one of the fundamental things as a physical therapist that you will learn very early on as you learn about human movement and as you learn about biomechanics. I thought I would take today to continue the theme of helping those students that are getting ready to start a DPT program to understand some fundamental concepts about human movement. So we have this thing called the convex concave rule. And the convex concave rule helps us to understand how two bones move, but more importantly, how two joint surfaces move. So let's take as an example the humerus and the scapula. The humerus moves relative to the scapula. Now, we know that the scapula can also move on a fixed humerus, but we're going to just start simple with the distal segment moving on the proximal segment. Now, we call movements of bone on another bone osteokinematic motion. It is the movement of the humerus on the scapula. But in addition to the humerus moving on the scapula, we have joint surfaces that are moving one upon another. In this particular case, we have the humeral head moving on the glenoid. And to fully understand how these joints move, we need to understand the convex concave rule. Most joints will have a convex component, and a convex is going to be like a ball shaped. And then we have a concave surface, which is going to be cave-like. It's going to be hollowed out. And in this particular case, the humerus is convex and the scapula, the glenoid, is relatively concave. Not as concave as I'm making out to be my hand. It's more of a very subtle curve, but it is concave nonetheless. When one bone moves on another bone, we use the convex concave rule to describe the arthrokinematic motion. Arthrokinematic motion is the movement of one joint surface on another joint surface. So in this particular case, the humerus can do various things relative to the glenoid. We typically think of arthrokinematics as roll, glide, or spin. Those are the most basic arthrokinematic motions. So for every osteokinematic motion, bone on bone, there is an associated arthrokinematic motion, roll, glide, or spin, and we define the roll, glide, or spin, particularly roll and glide, relative to the convex concave rule. So the convex concave rule says that when we have a convex surface moving on a concave surface, the glide is going to be in the direction opposite of the bone movement. So in this particular case, if I were to raise my humerus, depicted by my forearm, relative to the glenoid, the bone would be going up, say, into flexion or abduction, but the glide would be in an opposite direction because it is convex on concave. If we were to move a concave surface on a convex surface, we say that the glide is in the same direction as the bony movement. Now, people can get their heads completely, wrapped around the axle here and really struggle to understand the concept, in part because I think they get confused about the roll and the glide. I think the most important thing to keep in mind is the direction of the glide of the surfaces relative to the movement of the bone. So very quickly, as you get into physical therapy school, likely in the first semester, you are going to be exposed to the convex concave rule, and it is a fundamental concept that you will have to spend quite a bit of time with to be able to fully understand. My advice to you is, when you are exposed to the convex concave rule, you take a skeleton, you take skeletal pieces, the humerus and the scapula, and you try to apply the rule to the movement so that you can visualize and see how the rule applies. I'm going to suggest to you that there is an article that I would strongly encourage you to read. It is by Dr. Newman, and Dr. Newman describes in this article the concept of roll and glide, and dispels a lot of clinical rumor associated with the convex concave rule. The convex concave rule is an important rule for you to understand clinically how to apply it, but it is important for you to understand biomechanically how the human body moves. So I hope this is a prelude to additional instruction you will get in school, and maybe you'll come back to this video later as you are introduced to the convex concave rule.